Okay, in this video I'm going to show you how to make a NAND logic gate. Before we continue, I'll show you the truth table. You have two inputs A and B and output X. You should see that the output X is high unless A and B are high. The circuit symbol for this is as follows. It's the symbol for an AND gate with a circle at the end. If you ever see a circle, that means it's knotted, or there's a NOT gate or something like that attached to it. This here is the Boolean symbol for not A and B, or NAND. So it's A and B, the dot is A and B, and the line across means it's NANDed or knotted. So it's A NAND B. Okay, down here I have the physical circuit that composes of this. Okay, or this is composed of, should we say. So I'm using a 9 volt input, which is not standard at all. It should be a 5 volt, and I have a 0 volt ground line. I'm using 1, 2, 3 by 600 ohm resistors, and I'm using 2 bipolar junction transistors. I'll speak about those in a moment. This here is a 3mm LED. These inputs A and B onto the base of my transistors are not connected to my high line or my low line. And what I'll do is I'll leave the wires on these just free, so I'm able to fiddle around with the A and B inputs and verify my truth table. Okay, down here, this is a bipolar junction transistor, just as we have up here. Points to note here, we have the base, the collector, and the emitter. If you want to know about that, see previous videos that I've put up. I said it's a BJT, or bipolar junction transistor. This particular one that I'm using is a BC547, otherwise known as a 2N2222 transistor. Okay, so let's build them. Here's a breadboard, or the breadboard that I'm using. I've already put some wires out here, here, and here, just to make life easier for me when I'm building it. Points to note are as follows. You have this line down here is a low line or ground line, and up here we have a high line at 9 volts. Here's my battery, black line for low and red line for high. So what I'm going to do is I'm going to build my gate, build my gate. I'm going to start by wiring up this transistor here. So I'll go from high through a 600 ohm resistor to the collector on my transistor. So what I'm going to do first actually is put in the transistor. So here is a transistor. I'm not sure you can see it very well, but on the right as you look you should see a rounded side, and on the left as you look you should see a flat side. The flat side, if you look at a flat side facing you, you'll have on the left your collector, in the center your base, and the right your emitter. So I will always have the flat side facing to the left of the video. So I'm going to put that in here. I'll give you a close-up in a moment. Next I'm going to go from the high line to the collector using my resistor. This brown wire here that I've already put in is the base, and on the base I'm going to put in a resistor, and in series with my resistor I'm going to have my input A. Okay, so you can see that we have the high line, that orange there, the orange wire represents the high line coming down here. You have the resistor into the collector, the base down to another resistor which is going into my green wire, which is disconnected at the moment, and that is my high line. Now you should notice here that this brown wire here is for my next transistor. Right, what I've built so far is this section here of my gate. What I'm going to do now is put on my second transistor in a very similar fashion, where I'm going to connect the emitter of transistor 1 to the collector of transistor 2. So here's my transistor. It's the exact same as my previous one. This brown wire here once again represents the base for that. I'm going to do the exact same thing as my previous one, where I'm going to put a resistor in series with the base, and from there onto the output, or the input B. This yellow wire here represents a ground, and I'll show you that up close now. So we have, get that in focus, there we go, I have the emitter on transistor 1 connected in series with the collector of transistor 2. This wire here is the base, so it's coming down through the base wire into the resistor on the base, and this yellow wire here represents output B, or input B. This yellow wire here represents a ground wire. So I'll show you that on our circuit diagram again. So So what I've done here is the brown wire is this wire here coming through the resistor into input B, and the yellow wire on the right hand side that's going out to ground is here. So what I'm going to do is put my output here, and I'm going to show that the output's on. I'm going to use a 3mm LED, which it will go down to ground. Just a point to note here, it's going to come out from where the resistor is on transistor 1 joining the collector. So this red wire here is going into the collector of transistor 1, and this orange wire here is going out to ground. So I'm going to put in, actually it's a 5mm LED I'm going to use this time. Once again, points to note on an LED are you have a longer and a shorter wire. The longer wire is for your high, or your high line basically, or your red wires. So I'm just going to put that in series there with it. And you can actually see it turn on there, but I'll just give you a close-up once more. So where can you best see that? Right, there's your high line down here coming into the resistor, which goes into the collector of transistor 1, and in series, or at that same point, I have this red wire coming out, going into my LED, which in turn is going to ground. There we go. So it's time to check the truth table for this. Remember, the truth table is that it should be, the output here should be high for every state except for when both A and B are high. So A and B are low and I get a high. A is high, B is low, and I get a high. A is low, B is high, I get a high. A is high, B is high, and I get a low. Just verifying the truth table, and that is how you make a NAND logic gate.